Right, so this is Science Paper 2, 2022 GCE. Specifically, I'm going to answer question 5b, which is coming from concentration. So the question is saying excess zinc metal was added to 200 centimeters cube. So this one is the volume of 2 molarity, which is M, of hydrochloric acid. Now, on this part here, always volume should be measured in decimeters cubed, unless you have been guided. But in this case, volume should be in decimeters cubed. Now, how it is here is like this: 1 decimeters cube is equal to 1000 centimeters cube. So for us to convert 200 centimeters cube into decimeters cube, we need to divide this 200 centimeters cube divided by 1000 centimeters cube. Then the answer is going to be what? 0.2 decimeters cube. Okay, so always you need to convert volume, or you need to convert the volume unless otherwise. So the first question is saying write a balanced chemical equation for the reaction. Now on this part here, zinc, it has the valence of 2. It has the valence of what? 2. So I'm going to say zinc plus hydrochloric acid. Then what is going to be formed here is zinc chloride plus hydrogen gas, which is H2. So now to balance the equation here, now remember I was saying zinc is having the valence of 2. Chlorine, it has a valence of 1, so which means they are going to interchange their valences. Okay, so now for us to balance this equation, I'm going to put 2 on the hydrochloric acid, so that on the reactants we are going to have 2 moles of hydrogen. Then on the products we are going to have 2 atoms of hydrogen. Then apart from that one, we also have 2 atoms of, let me say 2 moles of chlorine on the reactants, and 2 atoms of chlorine on the products. Then 1 atom of zinc on the reactants, and also 1 atom of zinc on the products. So the equation is balanced. Let's try to answer the question, which is question B. So question B is saying calculate the Roman numeral number 1, the number of moles of hydrogen gas produced in the reaction. Then Roman numeral number 2 is saying volume of hydrogen gas produced at room temperature. So what I'm going to do here, I'm going to do like this. I'm going to say, let me use the mole to mole ratio. The mole to mole ratio. So when I use mole to mole ratio, I'm going to use a balanced equation. So in this case here, let me display this one. So on this part here, we are having 2 moles of hydrochloric acid and 1 mole of hydrogen. So which means we need to find the number of moles of hydrochloric acid using the information in the question. So since we know that concentration or molarity is equal to number of moles over volume. So in this case here, for us to calculate the number of moles, we are going to say number of moles is equal to concentration or molarity multiplied by what? Volume. So in this case here, our volume, or let me start with concentration. Our concentration is what? 2 molarity, which is 2m, multiplied by volume, which is 0.2. This 0.2 is coming from the conversion of 200 centimeters cube into decimeters cube. Okay, so when you want to convert centimeters cube into decimeters cube, just divide the number that you have been given by 1000 centimeters cube. Then the answer that you're going to get will be now in decimeters cubed. So in this case, 2 molarity multiplied by 0.2. Then the answer is going to be 0.4. The answer is going to be what? 0.4 moles. So now this 0.4 moles, it is the number of moles of hydrochloric acid. So what I'm going to do here, I'm going to do like this. The moles for hydrochloric acid should be on the right side. So I'm going to say 2 moles to 1 mole of hydrogen. Then 0.4 to the number of moles that we don't know here. So I'm going to put just n, then cross multiply. So n multiplied by 2, we are going to get what? 2n. 2, 0.4 multiplied by 1, I'm going to get what? 0.4. Then from there now, I'm going to divide by 2, even here by 2. So number of moles is going to be 0.2. 0.2. Now this 0.2 is what? The number of moles. The number of what? Of moles of hydrogen. So the number of moles of hydrogen here is what? 0.2 moles. That's all. Then as for Roman number 2 is saying the volume of hydrogen gas produced at room temperature. Now, the volume of any gas at room temperature, 1 mole is equal to 24 decimeters cube. 1 mole of any gas at room temperature, it is equal to what? 24 decimeters what? Cubed. So in this case here we have 0.2 moles of hydrogen. So which means I'm going to say 0.2 moles of hydrogen multiplied by what? 24. Then the answer is going to be 4.8 decimeters what? Cubed. Since I'm saying 1 mole is equal to or is equivalent to 24 decimeters what? Cubed. Which means where there is more, I need to balance up, okay? So we are having 0.2 of moles of hydrogen. So which means we are not supposed to put where 24 is, because where 24 is, there we are having what? The volume. So which means this 0.2 we need to put it to the other side of what? Of moles. Then we cross multiply. Then the answer is going to be what? 4.8 decimeters cubed. Okay. Then the last one, which is C, is saying what mass of zinc was used in the reaction? What mass of zinc was used in the reaction? So what I'm going to do here, I'm going to use also the mole ratio. I'm going to use what? The mole ratio. So I'm going to say zinc is having 1 mole. 1 mole of zinc, 2 moles of what? Of hydrochloric acid. Apart from that one, hydrochloric acid is having the moles of what? 0.4. So which means here we don't have the number of moles of zinc. So I'm going to find the number of moles here. So I'm going to say 0.4 multiplied by 1, I'm going to get 0.4. Then n multiplied by 2, I'm going to get 2n. Then when I divide, I'm going to get what? The number of moles to be 0.2 moles. Okay. Then from there now, since I know that number of moles is equal to mass over molar mass. So in this case here, we are finding the mass of zinc. So I'm going to say we cross multiply on this part here, so that mass is equal to the number of moles multiplied by the mixture, which is the molar mass. Okay. So the mass of zinc is equal to the number of moles of zinc. It is what? 0.2 moles multiplied by the molar mass. Now, the mass number of zinc here, it is what? 65 grams per mole. Since we are just having 1 atom of what? Zinc. Which means the molar mass is going to be what? 65 grams per mole. Now, 0.2 multiplied by 64. Let me say 65. Then the answer is going to be 13 grams. So this 13 grams is the mass of zinc, which is used in the reaction. Okay, so that was the last one. Thanks for watching.